This is a video from Module 4, Problem 10, and we're talking about a hypothesis test here. So we have, in a survey, 33% of the respondents stated they talked to their pets on the answering machine or telephone. A veterinarian believes this result to be too high, so he randomly selected 250 pet owners and discovered that 70 of them spoke to their pet on the answering machine. Does the vet have a right to be skeptical? Use the alpha equals 0.1 level of significance. So first off, you have to actually set up your hypothesis test. Now, your null hypothesis, also known as H naught, is always going to be your equal statement. So here we know that 33% of the respondents stated that they talked to their pets. So that would be that our null hypothesis is that the percentage, so the population percentage, equals 0.33, which is 33% as a decimal. We're always going to change our percents to a decimal before putting them into our hypothesis test. Then your alternative hypothesis, H sub 1, is the claim in this case. So here the veterinarian believes this is too high. So he thinks that it's actually less than that. So these two numbers will always be the same. It's the symbols that will change. The first one will be an equal to, and the second one will either be less than, greater than, or not equal to. And in this case, again, because the veterinarian believes it's too high, he thinks it's less than 0.33. Okay, now to find the p-value using your technology, we're going to go to StatCrunch. So if we press question help and then click into StatCrunch, we want to run a hypothesis test for a proportion because this is a percentage proportion. So we're going to go to stat, we're going to go to proportion stats. We have one sample. He took one sample of, I believe, 250 people, and we have the summary. We don't actually have every person's response. We just know how many responded that yes, they talked to their pets. So that's the summary. So here, again, the number of people that said they did speak to their pets was 70, and he had selected 250. So if I go back here, the number of successes is 70, and the number of observations was 250. And then we're going to put in our hypothesis test. So we had said that this is going to be 0.33. And again, see how it automatically switched this one to 0.33? Because they're always going to be the same. And then we have to switch the symbol to less than. Okay? And then we're going to click compute. Now here, this is going to give us lots of information, right? It gives us the sample proportion. So 28% of the 250 people that he talked to said that they talked to their pets on the answering machine. We have our standard of error. We have our z-stat if we were doing the conventional test, and we also have our p-value, which is how we're doing our test right now. Now the way the p-value works is that if the p is low, H naught must go. So the null hypothesis is rejected. If the p is lower than alpha, so if the p is low, the null must go. Here, our p-value is 0.0464. So we would go back here. They wanted us to round to 3 decimal places, so 0.0464 rounds to 0.046. And because alpha was 0.1, right? This is alpha, right here, 0.1, and p-value is less than alpha, it's 0.04. So because the p is low, the null must go. So we're going to reject H naught. Now, here's how the statements work. And I don't really agree with how Pearson does their statements. I was always taught that we use, you have a claim, and if the claim is a null hypothesis, you speak in reject terms, and if the claim is your alternative hypothesis, you speak in support terms. And one thing we never do is we never conclude, because here you can never actually be sure if you're correct. You could always have performed a type 1 or a type 2 error. So we either use the language that we support the claim or we reject the claim. Here, right, we always assume that the alternative hypothesis is the claim, which it is in this case, because this is what the veterinarian thought, right? So because I'm rejecting H naught, it means that I think that this is true, okay? So the way that we kind of go through this, okay, we say that there is sufficient evidence to conclude that the population proportion of pet owners is less than 33%. Okay, now let's go through the other statements and say why they're not correct, because I think, again, this can be a little confusing. So the first statement is there is not sufficient evidence to conclude that the population of pet owners who talk to their pets is less than 33%. Now the reason we're not going to say that is because we've rejected H naught, so we do think this is true. So they're saying that it's not sufficient evidence to say that it's less than 33%, and that's why this one is not true. Letter B says there is sufficient evidence to conclude that the proportion of pet owners who talk to their pets on the answering machine is 33%. Well, that would mean that we've accepted, or we failed to reject technically, H naught. And that's not true because we've rejected H naught. So we don't want to support that statement. Okay. Letter C says there is not sufficient evidence to conclude that the population of pet owners who talk to their pets is 33%. Now, that is true. We actually have rejected H naught, right? But the claim was actually H sub 1, or the alternative hypothesis, right? So even though statement C technically is correct, there's not sufficient evidence to conclude that, we really want to speak in terms of this one because this is the veterinarian's claim, okay? So now letter D is true because there is sufficient evidence to conclude that the population proportion of pet owners who talk to their pets is less than 33%. So we're saying we believe his statement. We believe his claim. Okay, so again, that can be a little confusing, and I, apologize that it's a little bit off. But what I can do is I'm going to post to you when I send you an email a little table that kind of shows you my line of thinking with hypothesis testing in the language, and it might help a little bit to kind of weed out some of the other statements, even though they're not using the support and reject language that I was talking about. Let me know if you have